So let's look at how we will be working with the ln and e. We've got a beautiful worksheet with Euler's number and natural logs from Eleanor Roosevelt High School in New York. The maths department prepared a beautiful worksheet which we're going to use. They also did all the answers. So what I'm going to do is just to show you how to get to those answers. And it's very important that you practice, because you will need to practice the notation. So in the first question, they ask you to simplify, and that's the basic use of laws of exponents. So you're going to do it on your own. We're going to start with question number 2, and let's look at a very basic question 2e, right? When they say evaluate a log with a base e, so ln of square root of e. But you know that there are no square roots between my laws of logs. Everything is with the rational exponents. So this can be changed into, using a first law, half log base e, so ln of e. Okay, but what is ln of e? Well, according to our laws, and we know that log base a of a is always 1, because only that number to power 1 gives me exactly the same value under the log, which means that ln of e is also equal to 1. So this answer is just half times 1. Question number 2J is a basic manipulation using a second law of logs. So you've got a log base e of 2 plus 2 logs base e of 3 minus a log base e of 18. I will soon stop talking about a log base e and just keep on saying a ln. In order to use the addition of logs with the same base law, you must remember that the coefficient in front of the logs must be 1. So this becomes a ln 2 plus ln 3 squared minus ln of 18. So we are looking at addition of 2 logs with the same base, which can be changed into a single log of that base with multiplication of the terms under the log. Looking at the next one, when we are looking now at the subtraction of 2 logs with the same base, which leads to a single log of, sorry boys, once again, thinking too far ahead. So it will be a subtraction of 2 logs with the same base will be a 1 log of division of the 2 values, which is a ln of 1. What will ln of 1 be? Well, think about it. Log of any base of 1 is equal to 0, because any base only to the power 0 can give us an answer of 1. And it's the same. Ln 1 will be equal to 0. Okay, a very nice questions to get used to a notation. Your question number 2, question number 3, please just practice. We're going to look at a solution of basic equations with ln and e, and that is question number 4 and question number 5. In question number 4, 4a starts very simply when they say solve for x if e to the x is equal to 4. Very similar example to your metric question when they say on a normal maths solve for x when 3 to the x is equal to 5. How would you solve this example? Well, I hope that you said that you would log both sides, preferably using a log base 10 if the question says correct 1 or 2 decimal places. Now, in this example, we've got an e, we've got a Euler's number, so we don't want to introduce a log base 10 on top of log base e. So we want to stick to a 1 log. So in this case, we're going to ln both sides. Now, if I ln both sides, then the power I can take to the front, because that's the same with all the other laws of logs. So it's x ln e is ln 4, right? So what is ln e once again? Ln e is 1. Therefore, x is ln 4. Now, if they say without the use of calculator, this would be your answer. If the general instruction is correct to 2 decimal places, then you go to your calculator, you choose a ln 4 equals, please take your calculators out and make sure that your answer is 1.39 for this equation, right? So let's look at the next examples to solve. I'm going to take question number C and question number H from number 4. In question C, we have to solve for x if ln of 2x minus 1 is equal to 1, right? So if that was a log equal to 1, log base 10, log base 3, you would use definition. And it's the same in here, right? If I have log 3 of 2 equals to x, how we change it into exponential? We say 3 to the x is 2, right? So in this case, e, because that's the base here, e to the 1 is 2x minus 1. Now remember, e is just a number. So I have 2 to the x is equal to e plus 1. So x will be e plus 1 over 2. Please pause it, take your calculators and determine x. I hope that you all got 1.86 if we want to take it correct to 2 decimal places. Okay, the next example, example number H. We have to solve for x if e to the power of e to the x is equal to 5. Okay, interesting. But to get the power down, we need to log both sides. In this case, we need to ln both sides. So I have power down e to the x, ln e is equal to ln 5. Okay, so I jumped over that one step of taking a ln on both sides. I hope that you can follow. Right, so this is equal to 1. So I have e to the x equals to 5. So we are back to our first example. What must I do? Well, I need to ln this again. So it's x ln e is ln 5. So x is equal to ln 5. Need to do it correct to 2 decimal places. You need to take your calculators and check the value of x. If it says without the use of calculator, this would be our answer. Okay, so not much difference, boys, between the ln and the e. To your normal log base 2 or 3 and 2 to the power of 2 or 3, it's just a notation that you need to practice. Let's look at 2 or 3 examples from question number 5. The first example from question number 5 is question 5F. This example is very important for mathematics, also for normal maths, because in the moment you replace e with 2 or e with 3, it becomes one of those level 4 type questions for normal maths. So I hope you remember from the revision that if we have a combination of 2 to the x and 2 to the minus x, it's our trinomial, so I need to first get it in a standard form. Now I want to analyze. I see that there is a e to the x, there is a e to minus x. I can, if I want to, if it's easier, use a k substitution. So I will have k plus 4 over k minus 5 equal to 0. Okay, so k squared minus 5k plus 4 will be equal to 0. And if I factorize, it's my k minus 4k minus 1 is equal to 0. So k is 4 or k is 1. Okay, e to which power will give me 1? Well, not just e. Any number only to the power of 0 will give me an e. Okay, if e to the x is 4, then x ln e is ln 4. Now this part you can avoid. You can just write x is equal to ln 4 from definition. Remember, we use a definition of logs as an inverse of exponents. And if it's without the use of calculator, this would be our answer. You can pause it, you can try to do it again. The last question we're going to look at is question J. In question J, we've got a ln of x squared plus ln of x minus 2 is equal to 0. Now remember, with the statements from the previous worksheet, true or false, is ln of x squared equal to 2 ln of x, is it? And the answer should be no, it is not. Right, it's not the same. So here, if I use a k substitution, if I make ln x a k, then I've got k squared plus k minus 2 equal to 0, which I can see that it factorizes as k plus 2, k minus 1 equal to 0. So we get k equals to minus 2, so ln x is minus 2, or k is equal to 1, so ln x is equal to 1. Be careful, you're quite quick with discarding negative answers. We discard negative answers if the exponent to the power of x is negative, because any base to any power will always be positive. But here, remember, we've got a base e. So this, by using a definition, is e to minus 2 is x. And it gives me perfectly good answer for x, because remember, e is just a number. So on your calculators, second function, ln, gives us e to the chosen power. We want to the power of minus 2, and we get 0.14 if it is correct to 2 decimal places. On this side, it's e to the 1 is x. So x is e, or you look at your calculator, or you use your calculator to get an e, you press the alpha button, and then the e is at the bottom row, equals, or you remember that this is 2.718 or 2.72 if you want correct to 2 decimal places. I hope it makes sense. I hope that you don't find it too difficult. It's a very short section of work, and I would like you now to do the homework from Eleanor Roosevelt High School worksheet on Euler's number and natural logs, and what to do as a homework is written in your weekly planning. Thank you, boys. Enjoy it.